All right, so welcome back. And we need to talk about the mobile phases, or AKA the carrier gases. What is a carrier gas? What does it do? What's the purpose in the GC system? What is this stuff that's known as a carrier gas? All right, so first and foremost, what you need to understand is that I abbreviate mobile phase with a M and a P. So this is my lazy way of typing mobile phase every single time that I need to do it. All right? Mobile phase, that's the term that I traditionally use. However, many people use other terms, and one of those is called a carrier gas. Carrier gases are typically the old school form, or what I would call the old school term that people back in the day used that they continue to use. But now we really talk about mobile phases. All right? So the mobile phase is typically a gas. And for GC, I'm going to say every time that you will see it as a student or a competition member will be in form of a gas. All right? So this gas is used for gas chromatography. And this gas is what pushes our sample through the machine. If it wasn't for this gas, then our samples would not be pushed through the instrument. And we couldn't really get data from our samples because of that. All right. Now, what type of gas is traditionally used for mobile phase? That's something that we have to answer, and it's pretty important that you understand what choices are out there and available for you. So, helium is a choice, hydrogen is a choice, and nitrogen is a choice. These three are the major players for gas chromatography. If you are running a GC system, doesn't really matter what type of GC system you have. But if you're running a GC system, you're probably running helium, hydrogen, or nitrogen for your instrument. Now, there's some good things and some bad things about each one of these, and let's discuss them. So first, I want to start off with hydrogen. Hydrogen is the smallest atom on the periodic table. Because of that, hydrogen gives us better separation because it's tinier. And if it's tinier, it can really go into the nooks and crevices and find its way in the column and find its way and mix with the sample really, really well and start to separate them one at a time much better. The problem with hydrogen is that it's explosive. Okay, so if you really need your stuff separated, then you're going to put your life on the line using hydrogen. Because this stuff could blow up, and boom, goes the lab. And boom, goes you. Then you can't run the GC anymore. Now that would be sad, wouldn't it? All right, so hydrogen is the smallest. Hydrogen does the best separation method. The problem is that hydrogen is explosive. Now, we don't really keep hydrogen tanks in the laboratory. We generate hydrogen as we need it. And we have something called a hydrogen generator that does that for us. And this basically uses water. And water's H2O. And it takes water and it breaks it up and it releases the hydrogen content from water and it feeds it to the GC on the spot. So that way we're not lugging around explosive hydrogen tanks and sitting them in the corner of the laboratory to blow up at any point in time. Next step up is going to be helium. Okay, now helium's number 2 on the periodic table. So helium is pretty small. Not as small as hydrogen, but it's still small. So Helium can do a pretty good job at separation as well. So that's good news. That's what we want to do. That's why we're running it in the GC in the first place, right? So if hydrogen is small, helium is just a little bit bigger. Hydrogen does a good separation technique. Helium does a good separation technique. Hydrogen's explosive, but helium is very inert. I mean, go to Party City and tell them to blow up their balloons. They're going to have rounds of helium tanks against the wall that they're going to use all day long to blow those balloons up. Helium is pretty inert. Helium is not very dangerous, really. You can put your mouth on a helium nozzle and suck the helium into your lungs, and then you talk like this. And it's all fun and games and people laugh. Right? So helium does away with the danger that hydrogen might present itself with if you decide to use hydrogen in a laboratory. Well, if you use helium, you can kind of do the same thing, but you can leave it trust in helium that it's going to behave itself and not blow up in your face. Our third option is nitrogen. And nitrogen, this is a little larger. And because of that, the separation on nitrogen is not as good as it is with helium and hydrogen. Nitrogen can be used for particular purposes, but in modern day time, what we're actually finding out is that nitrogen is getting used less and less and less. So, out of the three, nitrogen ranks in at number 3. Kind of dead last. It's large, it's bulky, it doesn't separate well. I mean, even if it was inert, and it pretty much is, it's not going to do a very good job for you. So because of that, we don't really even use it anymore. Number 2 would be hydrogen. And the reason is because even though it does a very good job separating, and even though hydrogen is the smallest and it can get into those nooks and crevices and really separate things very well, the problem is that it is explosive. And because of that, we don't want to use it unless we have to. And that means that helium is your number 1 carrier gas in the machine. Almost every GC has a helium tank installed on it because helium is the select gas of choice when you run a GC unit. Our GCs run off of helium. Many of the laboratories that are local, those GCs, the majority of them run off of helium. If you go outside of New Hanover, Pender County, and start looking at major employers that are statewide or national or global wide, these GC systems typically take helium. That's just the round of gas that we use. It's comfortable, it's clean, it's inert, it doesn't react, it's not explosive, it's small, it does the job. So therefore, helium, we're good to go. Now, whichever gas you decide to use, doesn't really matter. But with every gas that you decide to use, these gases typically have to be filtered. They either have to be filtered by the person that you order the gas from, or they have to be filtered what we call inline before it goes into the GC system itself. And this is why. All of these gases have contaminants. This is no surprising, right? Everything's got contaminants. Everything is dirty, and we've got to clean it up. So when Party City orders helium to blow up their balloons, they are ordering dirty helium, filthy helium. Stay away from it because it's bad. Well, that helium blows the balloons up. That's the only thing that they're doing. They just want to blow a balloon up and have it float. So they could care less about how dirty that gas is. And they order their helium much cheaper because of that. However, if we're talking about a GC system, this GC has to have mobile phase, which now we know helium is there, to go into that box. And we know that this GC sees things and it reports on what it sees. And if we get dirty or contaminated gases that go into the instrument, then we're going to get dirty or contaminated signal that comes out of the instrument. And that's something that we don't want to have. So because of that, sometimes when we order helium, some people will order dirty helium because it's cheaper. And what they do, it's like your water system maybe at home. They send it through a filter before it goes into the GC box itself. And we call this an inline filter. The filter's made up of different substances and materials. It removes water, it removes maybe some slight traces of hydrocarbons. It removes a number of different things from the gas sample itself. Well, that filter can be used. It doesn't have to be used, but it can be used if you want really good data. However, at the same time, some laboratories, and this includes us, we do not like to order dirty helium. We like to order very clean helium. And we like to order helium that's 99.999% pure. We call this 5 niners because there's 5 nines. 99.999%. That means there is very little slight trace of any contamination or dirtiness at all. However, in our laboratory, even though we order the 5 niners to run, we still have an inline filter that's in between the helium and the GC unit because we still don't want trash to get inside of our GC system. Because this thing's expensive. And we would rather take the extra steps of paying a little bit more for some cleaner gas and still including the use of a filter just to remove all the dirtiness that we can before it goes into this really expensive piece of instrumentation. All right? So that's the purpose of the inline filter. That's the gas that we typically use, helium. And the purity of the gases that we normally have in our lab are 5 niners. So if I ever had to call a company up and say, listen, I'm out of helium, they're going to go, what grade? Only thing I have to tell them on the phone, 5 niner. And they'll know exactly what I'm talking about. All right? So in the next video, we'll continue on with the definition of a carrier gas, and I'll show you maybe more details about the inline filter and some things to watch out for when it concerns your carrier gas or your mobile phase.